In tech support, one of the questions that we ask quite often is, how's your airflow? And the answer that we get most often is, it's good. This answer tells us usually that the technician has not even thought about airflow and really doesn't know what the airflow in his system is doing. In this video, we're going to talk about some ways that you can check your airflow and make sure that your airflow is good on a system. Before making major decisions on charge or other system issues, always make sure you have correct airflow. Always check the filter or filters. Homeowners always tell you that they change their filter religiously, which they normally don't. And many times homeowners don't even know where the filter is. And so sometimes they might add filters to the system, which is going to cause problems down the road. Make sure the blower is clean and no insulation has fallen off the sides of the cabinet to restrict airflow. Check that the blower motor is on the correct speed taps or the dip switches are set correctly for the correct airflow. Make sure that return air is the correct size for the system. Make sure that all the supply grills are open and not covered in any way. Check all ductwork for any areas that could be causing turbulence in the airflow, affecting system airflow. Let's look at a couple of ways to determine our airflow. If you happen to have a Carrier or Bryant communicating thermostat, in the service menu you can check your indoor airflow CFM, and the thermostat will tell you what CFM you're moving through the system. The first method is your temp rise method. This is where you take the temperature rise through the furnace, and then you take your amp reading and your voltage reading off the heat strips on an air handler. Then you use the formula CFM equals volts times amps times 3.414 divided by 1.08 times your delta T. This will give you the CFM moving through the system. Then we can check the CFM on a gas furnace by using this equation. And in this equation, we need to know the BTU output of the furnace that we're checking. In order to get the BTU output of the furnace that we're checking, we need to know the cubic feet per hour that the furnace is burning. And we also need to know the BTU content of a cubic foot of gas. To get the cubic feet per hour, we need to clock the gas meter. We have a video on our website that shows you how to clock the gas meter if you don't know how to do that. Then to get the BTUs of 1 cubic foot of natural gas, you can either call the gas company and get that ratio, or you could use a rule of thumb that 1 cubic foot of natural gas releases 1,050 BTUs of heat. Then once we have the BTU output of our furnace, we plug that into the equation. CFM equals the BTU output of the furnace divided by 1.08 times the delta T temperature difference. Another way to determine CFM through any air handler or furnace would be to use a static pressure check with a manometer. You could use either the older Magnahelix, a slope type gauge with a liquid in it, or the new digital manometers. Every manufacturer puts out air delivery tables for their air handlers. By reading the static pressure on a particular system, you can go down that column of the static pressure you're reading on your system and read what CFM is being delivered through the ductwork from that air handler. Another way to check airflow in a system is by using an anemometer. There are two different types, a small vane type, which has a little fan on it, which when stuck into a ductwork or into the airflow will read CFM or feet per minute on the dial. And then there's also the hot wire anemometer, which is the most accurate of these instruments, and they will read direct CFM or feet per second out of a ductwork.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.